Hi dear students, we are discussing about again set theory part 2 it is. We have again part 3 also for union and intersection, and then some miscellaneous problem, that is part 4. There are total 4 videos for this. This is part 2 video. Part 1 video is live class video I have uploaded. This is part 2. First we will discuss about what is power set in this. Power set is nothing but, see, let us consider one example. A boy and 3 balls A, B, C, correct. Now he is looking in how many ways the boy can play with these balls. Let us see here how many ways he can play with these balls. So he can take first ball A ball or B ball or C ball, correct. So there are 3 different ways he can select A, B, C, 1, 1, 1, or else he can take 2 balls A and B, or else he can take B and C, or else he can take A and C. So these are the again one more 3 more possibilities, or else he may take all the 3 together for the playing. Yes, yes. So now when you made these cases, look at this here. What exactly you have done? That is one ball, one ball, two balls, and all the 3 balls you have selected. Now see here what I do. There is the chance that the boy may not play with the ball also. He may say that, array, I don't want to play. Then he cannot select any ball. That is what we call empty. So these are all the possible ways a boy can play with these balls. Yes, yes. Now look at this. So we have listed all the subsets of the given balls. One ball, two balls, 3 balls, no ball. Okay, yes. So then this is what definition we can define now properly. The collection of all subsets of set A is called the power set of A. The collection of all subsets of a set A is called power set of A, and also it is denoted by P of A. Now let us take an example. If A equal to singleton 1, then subsets of A are empty set and singleton 1 only. P of A equal to singleton and no element. So if number of A is 1, then number of P of A is 2 raised to 1, because 2 sets you got here. So then similarly now I can take example 2. I take set B having 2 elements, correct. So then when I take 2 elements, then subsets are singleton 1, 2, 3, 1, 2. So now here power set of B are, they are same thing again. I am writing within the braces here, within the brackets, correct. Now look at this. So number of elements in this B are 2 raised to, number of elements in B are 2. Number of power set elements are 1, 2, 3, 4. So therefore it is 2 raised to 2. You can say it is 2 raised to 2. Look at this, correct. Yes. So now the power set generally, look at this third example you can take. One more we can explain. Take 3 elements. What are the subsets you can form? These are the possible cases, having 1 element, having 2 element, and having 3 elements. So all the power set of C becomes all these sets whatever I have written right in the within closed bracket. Okay, that is what I have marked in the black. Yes, these are all the subsets of a set A. Now number of elements in C is 3. Here the given set C are 3. What are the number of elements in this one? They are 8. How we can write 8? It is 2 raised to 3. So that is 2 power number of elements in the given set. It is always correct. Yes. So now let us see an example. A is an empty set. What is the power set? If you take A is an empty set, no single element. Yes. So then power set of A is also again empty set. Then note that power set of A has one element. Don't say no elements. So that is number of A is 0. Then number of P of A is 1. That is 2 raised to 0. You can say it is 2 raised to 0. Yes. Now finally you can say here, look at the structure. Whatever we have studied, see here all the things. Number of A 0 means probability, number of power set is 2 raised to 0. Number of A1 means number of power set is 2 raised to 1. Number of A is 2 means number of power set is 2 raised to 2. So and so on. So if A is the set with number of A is m, then number of subsets is 2 raised to m. अगर आपके पास सेट में ये m number of elements है, then total number of elements becomes 2 raised to m. Yes? Very good. So the number of proper subsets are 2 raised to m minus 1. In the proper subset, we don't consider the given set. Means the whole set we don't consider. That's the reason one element will be less. If they ask total number of subset, it is 2 raised to m. If they ask proper subsets, it will be 2 raised to m minus 1. Here I am showing you what is the definition of that. If B of A is subset of A and B is not equal to A, then B is called a proper subset of A. Yes? Yeah. Next we will take a question. Write down all the subsets of the following set. The set contains one element. Already we have practiced this. Yes. The subsets are these. So the power set becomes empty and this one. Correct? Yeah. So it is, we know that 2 raised to n. Then take 2. Therefore, there are 2 raised to 2, 4 elements. So the subsets are no element, one element, B, A, B. Yes. So there are 4 different subsets we can form here. Yes. That is the formula 2 raised to n. So now 3 elements. The set contains 3 elements. Then therefore there are 2 raised to 3. That means 8 elements we have to get in the power set. That means subsets. Take all these. Yes. The power set again, once again we read the same, all these sets. Correct? Yeah. Now total number of elements is 2 raised to n, that is 2 raised to 3, 8. So D is empty. The set contains 0 element. So therefore the power set becomes only one element. The subset is this. Hence we know that it is 2 raised to n. Yes. Question number 2. How many elements has P of A if A is pi? Only one elements. Since A is pi, no number of elements in A is 0, but total number of subsets is 2 raised to 0. This is very important, and hence it is total number of subsets is 1. Don't forget, P of A has one element. Don't say 0 element. Okay. Let us consider the real number set from minus 4 to 3. Consider when minus 4 to plus 3. Yes. Can we say that it is a subset of R? It's a part of R? Yes. As every number from minus 4 to 3 is a present in R, it is a subset of R, because every set, whatever the numbers are taken, this is from here only. So you can say it is a subset of R. Now, in general, for any AB belongs to R and A less than B, the numbers from A to B is called an interval. Once again I repeat, any A and B belongs to R and A less than B, the numbers from A to B is called an interval. Say for example minus 4 is less than 3, minus 4 to 3, minus 4 to 3 is called an interval. Yes. So types of intervals. Closed interval. Let us consider the real number line. If we take the numbers from minus 4 to 3, once again the same. See here how I have marked dark one. This is. And the next here we include the numbers from form minus 4 to 3 along with the endpoints. So therefore such an interval is called a closed interval. Here dark circle means it is included. Okay. Yes. Definition of the closed one. A, B belongs to R and A less than B, then the set of all real numbers for X, where X is in between A, B, X belongs to R, is called a closed interval. It is denoted by square bracket of AB. And then next, open interval. Let us consider the real number line, and we take again numbers from minus 4 to 3. Here we have made open circles. This is very, very important. Hence here minus 4 to 3. Yes, such an interval is called open interval. But remember, minus 4 and 3 are not included, not the endpoints. Definition. Again, look at this. A and B are not equal. Sign is not taken here. It means X is more than A, less than B. Okay? Yes. So it is denoted by open interval. Earlier it was square bracket. Yes. Half open, half closed. You can also say it is. Yes, if we take again numbers from minus 4 to 3, yes, what I have done here, left open, right close. Okay, you can say left half right open. Okay, yes, we include the numbers from -4 to 3 along with the last point. Such an interval is called half open, half closed. Yes, definition. Again, same definition. Only thing remember here, in every definition I am changing equality, not equal. Here it is a less than x and less than or equal to b. It's called half open, half closed. So it is denoted by open left side, closed right side. Okay, because it is open here, it's closed here. Yes. Half closed, half open. Let us consider the real number line. Once again, half closed, half open. It is right side open, right half open. Yes. Called half closed, half open. You can also say left closed, right open. Once again the same. Here I have taken equality sign here. It is only B, not equal. Okay. Yes. It is denoted by this. Okay. Note. Interval provides an alternative way of designating the subsets of set of real numbers. Remember, read carefully. Note 2. 0 to infinity defines a set of non-negative real numbers. It is always defines non-negative real numbers. Note 3. Minus infinity defines the set of negative real numbers. It is non-negative. It is negative. You can say set of positive real numbers also. But 0 included here. That's why we say non-negative. Okay. Yes. Note 4. It defines minus infinity to infinity defines the set of all real numbers. Very important, all these 4 notes. Remember this. Okay. Yes. So we go for the next. Write the following as intervals. Question number 1. So -4 to 6. Here 4 is not included. 6 is included. Yes. Solution for this. Observe that -4 is not included. 6 is included. Correct. Yes. Now take it. -4, 6. So for that, -4 included, 6, -4 not included, open, here it is included, close, finish. Second problem, take again same, both are not included here, therefore both are, yes, open interval, -12 and 10. Yes, third problem, 0 included, 7 not included, correct? Yeah, we can write it as left close, right open, 0, 7, correct? Yeah, fourth problem, 3 included, 4 not included, correct? 3 is included and 4 is not included, correct? 3 close, 4 open. Yes, understood? Next one. Write the following as intervals in set builder form. -3, 0. Solution is very simple. X, I can say here, X is a real number. We observe that -3 and 0 both are not included. We can say less than X less than 0. So this is the answer. Next problem, both are included. X is a real, X 6 and 12 are included. You can say X is in between 6 and 12. Correct? Yeah, this is fine. 6, 12, 6 not included, 12 included. Correct? Very good. I'm just making little bit faster. Why? Because it should not be a lengthier video. Yeah. Left included, right not included. Correct? Yes. Next problem, we go for universal sets. A set which is a superset of each one of the given set is known as universal set. It is denoted as U. So for example, now let us say here, let us consider of set of domestic animals. Okay, I have considered one set of domestic animals here. So nice. And all animals here. Correct? First domestic and then all animals. Now dog is belongs to this, cat is belongs to this, cow, yes, rabbit is also belongs to this. Correct? Yes. Now look at this. For this, the superset is set of animals. For these animals, superset is this one. Means these are all belongs to this one. That's why this all animals is called a superset and these four animals is a subset, you can say. Okay. Yeah. Now look at this. Let us we go with the Venn diagram. In the previous module, we have seen how to represent sets in a roster form and set builder form, correct? Now let us view the relation between the sets can be represented by means of diagrams which are known as Venn diagrams. Venn diagrams are named after the English logician John Venn. Here, universal set is usually represented by a rectangle. Remember, and the sets are denoted by the circles, correct? Yes, and the elements by the points, correct? Yeah, look at this. Here universal set means all the elements 1 to 10. And what is the elements in set A? 1 2 3 4 5. Yes. Yeah, this is how we represent universal set and set. Now to represent the subsets of a set of real numbers through Venn diagram, look at this. Set n, correct? Yeah, whole set natural number, and again set of integers. Yes, look at this. Earlier I took natural number, whole numbers, and then set of integers, and the next it is set of rationals, etc., and the set of all irrationals, and together also it is a real numbers, correct? Look at how they are. Each circle represents their specific numbers. Means when you consider a rational, these are all belongs, natural belongs, W belongs, Z belongs. When you take Z, only these cases belongs. When you take W, N and this belongs. Only natural, this is the only number belongs. But all these circles belongs in the square, you can say rectangle. That's why these are subsets of superset R. N is subset of W, W is subset of Z, Z is subset of Q, Q is subset of R. N is in W, W is in Z, Z is in Q, Q is in R. That's why they are all subsets. Yes. Now we go for a question. What universal sets would you propose for each of the following? The set of right angles. The universal set is set of all triangles here. Answer is set of all triangles. Second question. The set of isosceles triangles. The universal set is again set of all triangles. Yes. We go for the next question. Given that set A equal to 1 3 5 7, B is 2 4 6, C is 0 2 4 6 8, which of the following may be considered as universal set for all the three sets A, B and C? So first one is 0 to 6. Pi, and again third set, fourth set. I have considered four different sets here, correct? Now what they are interested, which of the following may be considered as universal set? Yes. Now look at this. 0 1 2 3 4 5 6, 7 belongs to A, but it does not belong to 0 to 6. 7 belongs to A, but here it does not belongs to this. So it cannot be a universal set for all the three sets A, B, C, correct? It cannot be the universal set for all these A, B, C. So then let us we take pi. Pi there is no element, so it cannot be the universal set. Yes. Next one, third, 0 to 10. When you look at all the elements here and look at all the elements of ABC, every member of this one are present here. So definitely you can take it as a universal set for ABC. So all the elements of ABC are contained in this. It is an universal set for the sets ABC. So 1 2 3 4 5 6 7 8 cannot be, because 0 is not, which does not belongs to this set. It is not a universal set. It cannot